Welcome to Machine Learning Lesson 4.4. In this lesson, we're going to see how we can take linear regressions to the next level by including additional features. This is called multilinear regression. But before we can actually start building our model, especially now that we're dealing with more features, we got to decide which features are the best ones to use. So let's get to it. So what I want to do is I want to start off by, just as motivation, let's look at the previous video's example, which was the linear regression one, where you simply took one feature. So in this data set, we were trying to predict the price, and we used simply the mileage. Now, hopefully your gut feeling says, that's not enough to figure out the price of a car. Obviously, the brand, the model, the year, all these things factor in some way into the price of the car. Scrolling a little further down into this particular example, after we created our model and fit it with our training data, we analyzed it by using the score function, and we saw that we scored 25%. That's a very low percent for a machine learning application. But again, we simply used one feature, the mileage, which is not a great predictor of price. So again, this is where multilinear regression comes in that you accept the fact that it's not just one feature, it's many features that contribute to the outcome of that target feature. But before we go any further, we have to analyze the features and figure out which one's the best one to use. So that brings us to our current collab, and as part of the development cycle, the first thing is always to include our library. So we have our pandas, we have our math plot. And what you'll notice here, even though we won't actually use them in this example, that we have the linear regression and the train test split, the same imports that we had for the linear regression. Again, multilinear regression is just an extension of linear regression. But again, we're not going to cover that in this video. In this video, we're going to focus primarily on analyzing the features. So let's run our code and let's see what is this data that we're working with. So this is not new data. We've seen this in previous videos. This is the one that has the miles per gallon, horsepower, weight, acceleration. So our goal in this application, this machine learning application, is to try to predict the miles per gallon based off of some of these features, not just one. Let's incorporate a couple of these features in our prediction of how many miles per gallon we would get from a car. So as with any application, when we're starting off, we're looking at the data, let's do a data.describe. And let's just see what we're dealing with. So the first thing we'll notice is that the car name was dropped. Because again, describe can only deal with numerical data. The other thing we'll notice is that it doesn't look like model year and origin contribute a whole lot to our data, in the sense that they look like they're pretty much all the same number. Now you might say the same thing for the cylinders, might be so. So what we're looking to do is we're going to drop some of these columns. I guess that's what I'm saying. We're not going to use model year, we're not going to use origin, we're not going to use car name. So let's adjust our data to remove those columns. Now if you recall from a earlier video series, a data frame has a drop function, which will allow you to specify which columns to drop. So let's do, what do we say, car name, model year, and origin. Let's not focus on those. And we also have to include, as you can see here from the pop-up, we have to include this extra parameter of axis is equal to 1, so that the computer knows that these labels that we're specifying are for columns, not for rows. All right, so let's run that. Okay, so now we got our data set up. And we could have done a data.head. As a matter of fact, let's do that. Just to prove to you that we've gotten rid of those columns and that we're only dealing with the first couple of ones. So the next step in this that I want to show you that's very useful is to do a histogram on the information. So a data frame has a hist function. Now you might say, well, wait a minute. A histogram, that sounds like a chart. Shouldn't that be part of the matplotlib library? Well, you're going to see something interesting here in a second. Size equals, and let me specify a size. Let's run this. Okay, so hist is a function of a data frame, which is part of pandas. But what you'll notice is that underneath the hood, pandas is using matplot. So this histogram function, what it does is that it kind of gives you the distribution of the information, which again, you might not be able to get that by looking at simply the describe function. Again, this is where matplot comes into play. So you can see that, acceleration is kind of grouped around here. For cylinders, we got looks like 200 of our 392 cars are 4-cylinder cars, and about another 100 or so are 8-cylinder. So primarily our cars are either 4 or 8-cylinder cars. The other thing you kind of see here from some of the other ones is a little bit of the dispersion of where your data lies. Now again, if you're a good statistician, you can get that information by looking at these quartiles as well. I happen not to be, but I will tell you, looking at this chart, it makes sense to me. This kind of shows me where my data is lying within each of these features. So again, another useful tool to kind of see which features might be useful in creating our predictive model. All right, so continuing on, let's do our old friend, the correlation function. And what this helps us do, this helps us find relationships between features. So if you recall, you could go up to 1 and up to -1. 1 gives you a positive correlation. -1 means it's a negative correlation. Don't think of negatives as being bad. It just means that it's inversely proportional to the other feature. So just as an example, obviously the diagonals will always be 1 because it's on itself. But let's take a look at cylinder. So if we look at cylinder and displacement, you'll notice that it has a very high correlation. So the more cylinders a car has, the more displacement it has. You'll also notice that it also has more horsepower and it weighs more. So something to look for. You definitely want to have stuff that has a high correlation either on the negative or the positive side. Something else I want to point out, let's look at displacement and weight. This is also a very high correlation. So the reason I bring this up is that when you go to select your features, if you select one, it might not make any sense to select the other one because they kind of increase at the same rate or in the same pattern. So by simply selecting, let's say, just weight, we're kind of already incorporating the idea of displacement because we know that displacement is going to increase with weight. Same thing here. If we include displacement, well, it doesn't make any sense to include cylinder because if our displacement is increasing, we know our cylinders has to be increasing as well. That's called collinearity. So you want to try to avoid features that have collinearity. Again, it's redundant. There's no need to add to it. So let's continue on. Let's see another way that we can analyze our data. Now for this next one, I'm going to cheat a little bit in that I already have code set up. And this next way of looking at your data does use matplot. So let's copy this code here. And I'll be honest, I have this code saved somewhere, and anytime I want to use this feature of this type of charting, I simply go to an example and I copy and paste the code. I'm not going to try to run you through the code. There's various matplot type code that goes into it, which is a little bit beyond the scope of this particular video. But I highly encourage you. Matplot is a very powerful library. The more you know, the more you can use it to analyze your data. So what I've done here is that this particular piece of code, this code segment, simply takes your correlation chart that we get from data.core, as you can see here, and then just charts in a nice visual pattern, which can be useful when you have a lot more features than what we dealt with here. Again, if you kind of imagine we had 15 features across, 15 features down, that's a lot of numbers to look at to try to figure out, which ones have a high correlation. But if you looked at it visually with colors, it might be easier to spot. So let's see if we could kind of prove to ourselves that this does have the same information as the numerical chart. So let's look at miles per gallon, and we can see here this is purple, and looking at our guide, purple, a really dark purple, has a -1, a negative correlation. So we have a negative correlation for miles per gallon in the weight, and let's see if we can find a positive one. So as a matter of fact, why don't we just stick with weight? So displacement and weight has a positive correlation. So we're going to go back up, and let's see, is that the case? So miles per gallon and weight had a negative because it was purple. Displacement and weight was on the yellow spectrum, which was closer to 1, which is a positive correlation. So again, it's really up to you. I would say with practice and with a limited number of features, you can simply do it this way, just doing the cores function from a data frame. But if you have a lot of features, this definitely will help you to visualize and kind of spot, wait a minute, maybe we should look at this one. So for instance, looks like acceleration and horsepower has a strong negative correlation. Let's just look at that. Acceleration and horsepower. Well, I don't know about strong, but it definitely has a negative correlation. So again, this is just one feature. And I would say you probably want to use a combination of different techniques to analyze and select your features. So the last one I want to show you kind of continues on with the same idea of kind of comparing features to each other. This one also comes from the pandas library, so it's plotting, scatter matrix, fixed size. So hopefully your gut will tell you, because I'm using fixed size, that somehow under the hood, pandas is using matplot. So let's take a look at it. Okay, and sure enough, as you can see here, we get a bunch of math plots. Actually, if you notice, it's an array. It's an array because it's all the information required to produce all these little individual charts. So let's see if I can kind of go down to some of the other one. And as the same thing as the correlation, the same thing as the visual correlation charts, this maps all the features against each other. So let's take a look at miles per gallon. Let's see if it speaks the same information as the other one. So we're seeing that miles per gallon and weight have a negative correlation. And that's because if you had to kind of guesstimate a line of best fit, it kind of goes this way. Let's look at horsepower, also negative. Displacement, also negative. This kind of explains to you that because cylinders really only has a couple of values, you're not going to get much of a kind of like a line of best fit with this. So let's look at that. So we're saying that miles per gallon had a negative correlation with weight, horsepower, and displacement. Let's look at this one, and sure enough, these were all purple, which was negative. And if we look at the numbers, you notice these are all negative. So let's try to pull up a positive one. So displacement and weight. So displacement and weight here is yellow, meaning a high correlation, positive correlation. And let's see, displacement and weight. Let's see, which one is weight? Weight is this one. And right here, the line goes this way. If you have to draw a line of best fit this way, it goes increasing, which means it's a positive correlation. And you'll also notice that horsepower and weight also has a positive correlation. Let's double check that one. So horsepower and weight, positive correlation. Horsepower and weight, positive correlation. So again, many different ways of looking at your data, but this is a very important step. Figuring out which features are best for you to use. So let's go back to our presentation and let's review what we've learned. So even though we haven't done an example, that's for the next video. Multilinear regression is an extension of a linear regression. It's not a separate object. It's just a different way of using linear regression. Because we're going to be using more features, it's extremely important to figure out which of those features are going to be able to help you in predicting what your target is. So hopefully you're ready for the next video, and enjoy.